So we're leaving it alone. This is the simplest possible form for it. And now we're going to differentiate. So what happens? We get, so again, what's the method? Let me remind you. You're applying d by dx to the equation. So you have to differentiate the left side of the equation and differentiate the right side of the equation. So it's this. And what you get is 2x plus 2y y prime is equal to what? 0. Derivative of 1 is 0. All right, so this is the chain rule. Again, I did it a different way. I'm trying to get you used to many different notations at once here. Well, really just two, just the prime notation and the dy dx notation. And this is what I get. All right? So now, all I have to do is solve for y prime. So that y prime, if I put the 2x on the other side, is minus 2x and then divide by 2y, which is minus x over y. All right? So let's compare our solutions. I apologize, I'm going to have to erase something to do that. So let's compare our two solutions. I'm going to put this underneath and simplify it. So what was our solution over here? It was a half 1 minus x squared to the minus a half times minus 2x. That was what we got over here. And that is the same thing if I cancel the 2's and I change it back to looking like a square root. That's the same thing as minus x divided by square root of 1 minus x squared. All right, so this is the formula for the derivative when I do it the explicit way. And I'll just compare them, these two expressions here. And notice that they are the same. All right, they're the same because y is equal to square root of 1 minus x squared. Yeah, question.
Bottom half of the circle.
The question is, why did the implicit method not give the bottom half of the circle? Very good question. The answer to that is that it did. I just didn't mention it. Well, wait, I'll explain. So suppose I'd stuck in a minus sign here. Okay? I would have gotten this with a different, so with an extra minus sign. But then, when I compared it to what was over there, I would have had to have another different minus sign over here. So actually, both places would get an extra minus sign, and they would still coincide. So actually, the implicit method is a little better. It doesn't even notice the difference between the branches. It does the job both on both the top and the bottom half. Another way of saying that is that you're calculating the slopes here. So let's look at this picture. Here's a slope. Let's just take a look at a positive value of x and just check the signs to see what's happening. If you take a positive value of x over here, x is positive, this denominator is positive, the slope is negative. You can see that it's tilting down. All right? So it's okay. Now, on the bottom side, it's going to be tilting up. And similarly, what's happening up here is that both x and y are positive, and this x and this y are positive, and the slope is negative. On the other hand, on the bottom side, x is still positive, but y is negative, and it's tilting up because the denominator is negative, the numerator is positive, and this minus sign makes it a positive slope. So it matches perfectly in every category. So this is complicated, however, and it's easier just to keep track of one branch at a time, even in advanced math. Okay? So we only do it one branch at a time.